بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الخلق والمرسلين. Inshallah, today I will be presenting my presentation for Project 1 of Logic Design. BCD to 7-segment LED Display Decoder Circuit by the student Faisal Al-Hazmi. What is a 7-segment display? A 7-segment display is essentially a series of 7 LEDs put together in a pattern that makes it so that if certain parts are lit up, they give me a certain number. So what does all of this mean? If you look at the diagram below, I have this diagram here. It's made up of 7 segments, so this is a 7-segment display. Each part is labeled. So this segment is segment A, this one is B, this one is C, D, E, F, and G. Now, if I wanted, for example, to represent 0 in this 7-segment display, how would I do that? I would do it by making A on, B on, C on, D on, E on, F on, and G off. So G equals 0. And if I wanted to make the number 1, for example, I would do it by making A off, B on, C on, and the rest off. To get this, the shape of the number 1. The same with 2. A on, B on, G on, E on, D on, the rest are off. And so on and so forth. Why a 7-segment display? The 7-segment display is a simple yet efficient way to represent the decimal digits 0 to 9 using only 7 LEDs. You only need 7 segments to display 10 digits, whereas others need more. The logic design needed to create it is very simple and cost efficient. So the minimum number of segments that I need to represent 10 digits is going to be 7 segments, which is one of its advantages. And it's also very cost efficient and it's good for beginners, as it's very simple to use. What are some applications of the 7-segment display? The 7-segment display is used in digital clocks and watches. You may notice that some old watches you have, or some old clocks you have, they use this 7-segment display. Calculators, even till today, they still use it. Electronic meters, such as ammeters, voltmeters, ohm meters, multimeters, some old oscilloscopes, some breadboards, they all use 7-segment displays. Digital counters, weighing scales, and many more. For example, in the gas station, when they want to fill up your fuel, the device has a 7-segment display. How do I convert from BCD to 7-segment LED display? BCD is a numerical representation scheme in which each decimal digit is encoded using 4 binary digits. So for example, 2 is going to equal in BCD 0010, and 1 in BCD code is going to be 0001. That is because the first slot is 1, the second slot is 2, the third slot is 4, and the fourth slot is 8. Since we can represent each decimal digit from 0 to 9 using 7 parts, which is the 7-segment LED, I can create a circuit based off of the BCD numbers that will send a positive signal to the parts of the display that I want to turn on. So the parts of the display that I want to turn on, so let's say for example I want to create 1, I'm going to turn on A and B. They will receive positive signals. So how do I go about doing this? First things first, I'm going to create a truth table so that we can find the equations of each part of the display. So I want to find the equation for A, B, C, D, E, F, and G. So for example, when we want to represent 1, which equals 0001 in binary, in BCD, we're going to need parts B and C to be lit up. Look at the figure on slide 2. So here, I'm going to need B and C to be turned on. So A is going to be equal to 0, B equals 1, C equals 1, the rest is equal to 0. So it should be 0, 1, 1, 0, 0, 0, 0. So 0, 1, 1, 0, 0, 0, 0. Let it be noted that we do not need any number that is greater than 9, and as such, we can list it as a don't care condition. The reason we don't need any number greater than 9 is because the 7-segment display can only display single digit numbers. So from 0 to 9, only these 10 digits can be displayed. No more. So anything that is beyond that, 10, 11, 12, 13, 14, 15, I can list them as don't care conditions. So in this truth table, with the 4 bits input in BCD code, which is going to be represented as W, X, Y, and Z, I have the seven letters, the 7 segments, which are A, B, C, D, E, F, and G. And let's say I want to represent 0. Here, the first one is 0. How am I going to do that? A is going to equal 1, B is going to equal 1, C is going to equal 1, D is going to equal 1, E is going to equal 1, F is going to equal 1. But G is going to be 0, so it's going to be 0 here, and the rest is 1. And if I want to represent 8, it's going to be 1, 1, 1, 1, 1, 1, 1. So 8 is going to be full. Notice that the number is greater than 9, which is 1, 0, 1, 0, until 1, 1, 1, 1, since this is the max number we can have in BCD, in 4-digit BCD. The input, the values of the segments are going to be X. I do not care. Doesn't matter what value they are, I do not need them. So we're going to use K-maps to find the respective equations for the 7 segments. So I'm going to want to find the equation for this, for A, B, C, D, E, F, and G, to find the link between this and the variables. So I want to find the link between A, the segment A, and W, X, Y, and Z, the code. Note that don't care conditions are M of W, X, Y, and Z are equal to the sum of 10, 11, 12, 13, 14, 15, which I can represent in K-maps, 10, 11, 12, 13, 14, and 15. So here I have the K-maps for A, B, C. Notice that I have WX vertically and YZ horizontally. And I have color-coded the squares to make it clear for the viewer. So for example, XZ is in orange, XZ is in orange here, so 1, 1, this doesn't change, so it's going to be X, and 1, 1, this doesn't change, so it's going to be Z, XZ. I do the same for B, I do the same for C, the same for D, the same for E, the same for F, and the same for G. And once I have these relations, once I have found the equation of the 7 segments, I can now represent these in a diagram. So we are going to be using the LogicWorks 5 software to design and simulate the circuit by using the equations we found via the K-maps. So after implementation, after using the LogicWorks 5 software, the circuit should look like this. It's very long, but this is how it looks like. So it's going to be the inputs here, 4 inputs, and 7 outputs. So W, X, Y, and Z. This is W dash, X dash, Y dash, and Z dash, and these are the terms, the sum of terms. No, sorry, the product of terms here. And they are going to enter these 7 outputs here. Notice that the dot here is unnecessary. It's optional. I do not need it because if I suppose it's on, this is going to go red. If I suppose it's off, this is going to be the same. And I do not need it. I only need this part here in the middle. But how can I, since this is very long, I want to make this look smaller. I want to make this way more clear. Because if I wanted to apply this in other circuits, I can't just put all of this down again and again and again. It's too long. So there's a way for me to create a custom part that has all of this put into a single block, which is called hierarchical. So step 1, I'm going to replace the inputs with the port in component. So these inputs, which were W, X, Y, and Z, I'm going to replace them with a component called port in. Clear? And then this part here with step 2, replace the outputs with a port out component. So the same way I did with this, I'm going to delete the 7 display, the 7 segment display. I'm going to replace the outputs with the port out. So 1, 2, 3, 4, 5, 6, 7. Correct. Step 3, I'm going to press file, new, press file, new, and device symbol. This device symbol, once I press OK, it's going to put me onto a page. Once I'm put onto the page, step 4, press CTRL Q plus Q, and copy the settings shown in the figure. So create a sub-circuit symbol and select an open circuit to attach to it. Choose the circuit which you have made and press OK. You should have, after adding the inputs and outputs, you will finally create the custom part, BCD to 7-segment display decoder. It's as simple as that. And here is how the circuit looks like with the custom block. So here I have the 4 inputs with the 7 outputs. And no, the dot is optional, we do not need it. And we will later be verifying whether or not the circuit is correct through the LogicWorks simulation, inshallah ta'ala. Thank you for listening, and I hope it was clear. Bismillah ar-Rahman ar-Rahim. Inshallah, I'm going to be simulating the logic circuit. So this is the block version, the hierarchy version. So I'm going to simulate this one first. This is 0. This is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And don't care condition, so it doesn't matter what I do. Now, as for circuit 1 with the block version, let's test it out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and don't care condition, so it doesn't matter.